CBTS, the cross-border threat screen for supply chain defense. And we have a webinar series, and we're very happy today to have Dataiku presenting some of the experiences they've been having on breaking silos. We've been engaging in conversations now for a few months because of the type of work that we're doing that is highly multidisciplinary, that goes beyond tech C&M and beyond government, industry, and even the border. So we're working across different countries, doing research with experts in different places with different backgrounds. And so this highly intensive project that is a set of projects that we'll be working on related to COVID-19 have pushed us to the limits on how can we better integrate our work. And thanks to the advice of our contractor, Victor Gutierrez, we came across Dataiku. And that's why we set up this presentation today so that we can learn about what they do. Greg, would you mind giving us a brief about what CBTS is so that today's participants can learn about our Center of Excellence?
Absolutely, thank you. So everyone, welcome. I'm Greg Pompelli. I am the director of the Cross-Border Threat Screening and Supply Chain Defense DHS Center of Excellence here at Texas A&M. We're housed primarily in AgriLife, but have a little bit of an appointment also with the rest of the system. So we are basically here to help DHS with research needs, and in particular, things that relate to biothreats. So we have got a number of agreements with Zenon and his teams. They're among our most successful, as we can see today, in terms of activity and also the delivery of the kinds of information that DHS and its partners can use. We've been around for about, we're going into our 4th year now, and we have another about 6 years to go on our agreement with DHS. So we are always looking for new ideas and certainly always happy to do anything we can to promote basically the distribution of great ideas. And so that's one of the reasons we're looking forward to today's meeting, because that's exactly what we want to see happening, this kind of exchange. So thank you and welcome all.
Very good. Thank you, Greg. And I just wanted to share a couple of thoughts before we introduce our speaker today. I think everyone in different organizations is trying to find the optimal technology integrator to make our work more efficient on a daily basis. And academics, we are not the exception to that. And we are well known for having very strong and thick silos that sometimes impede us to collaborate with others. And as it is the case in our project with CBTS, we didn't have the time to let us put barriers in the work that we needed to do, because we needed to support the center to provide actionable information that can improve decision-making related to supply chains that were impacted by COVID-19 and that are being impacted by COVID-19. So that's why learning about what Dataiku is doing now is of great relevance to our research, and I guess it might be for others as well. So that's why we wanted to bring this webinar across our Tech C&M community. So I would like to introduce our speaker today. Our speaker today is Catalina Herrera. She's a senior sales engineer at Dataiku. She has spent her entire career helping industry push beyond digitalization to business transformation. She has held both educational and technical positions, worked with state-of-the-art technology solutions across multiple industry verticals, and served as data scientist and SaaS technology evangelist. Well, welcome, Catalina, and look forward to hearing your presentation and learning about what you're going to present today.
Thank you. Thank you, Dr. Medina. And very nice being here today. We're going to talk about breaking silos. And as you mentioned, what this means, right? The power of collaboration and abstraction that we have over there. I'm an engineer. I have 3 master's degrees covering computer science, engineering technology, advanced electronic systems. I also learned a specialization in data science after a little further in my career. I started my career back in Colombia. So if you hear the accent, it's Colombian. And I was a professor at the engineer school where I discovered my passion for education. However, after teaching this class for many, many times, I decided I needed to complement my skills with experience coming from the industry. And that's where in 2004, I left my country, my culture, my family, my friends, my language to start my journey in the United States. My first data science job was at the Alternative Energy Institute in West Texas A&M, at the institute that was actually collecting all of this data coming from all of the wind turbines. And my first thesis was to create a book for the developers to understand the weather characterization, the direction of the wind, and all of that. So it was actually a data science project, even before we call it a data science project. And then I was working for Texas Instruments for a while as well, where the first day at work, I received a computer that already had a BI tool installed on it, Spotfire. So I was part of the Yale team, and we were the data scientists that were analyzing all this data to maximize production, which is at the end what we are trying to do, is to ensure that we are extracting all the benefits of all this data coming from all of these silos. And that's where I discovered the power of data. So for the last decade, I have been supporting multiple analytics and data science projects that are tied to specific business problems across many verticals. And that's why today we're going to talk about breaking these silos and what that means. So I'm going to start with an analogy. And this is how I see a silo. But before that, we're going to ensure that everybody here is in the same page when we think about silos, right? So a silo, it's a collection of data that is being held by a group of people or by a database, or it can even be a data table, part of an Excel file, but is not part of the common overview of all of these insights where you are thinking about solving a problem. And we will see how this goes in a practical example. You have data coming from all of these silos that can be a different group with a different perspective, a different set of variables coming from a different data source, or in general, more insights into that problem, right? So the analogy today in terms of the silos is, I see silos like horse blinders, right? You are limiting your perspective and you are walking only on that direction, and perhaps you are missing another set of insights or information that are going to allow you to have a better picture as in how to solve that problem or how to, move forward within that problem. So I believe that, like with life in general, like the more you know about something, the more educated the decision that you can make about it. So today I will talk about the power of not only breaking the silos, but also what it means within a data science workflow and what it means for us to maximize the use of these insights and ensure that we are using it towards the same goal, as we will see through multiple examples, right? So hopefully by the end of the presentation, the donkey on the right side is going to make a lot of sense, as in a nice smile thinking, okay, I have a better perspective here. This is going to make more sense. We have all the insights that we need to have in order to make a decision. So I'm going to talk about machine learning and AI, because at the end, you are breaking silos for a purpose, for a goal. And these machine learning and AI is pretty much the tools in between that are going to help you make the most out of these silos. So we can't talk about data science and machine learning without a little bit of history and background. And to put things into perspective, this is not a new concept, right? There has been a series of key mathematical and statistical breakthroughs starting back in the 1700s, where Bayes' theorem evolving into Bayesian probability, or with Ada Lovelace already writing what is considered the first true computer program ever published back in the 1800s, right? Or I'm sure you have heard of Alan Turing, and he was already saving millions of lives with applied data science back in the early 40s. And by the way, if you haven't seen the movie The Imitation Game, I totally recommend it. It's a phenomenal movie. Now, in the 1956, the term artificial intelligence was born when the Dartmouth Conference and John McCarthy and his team, a group of others, actually started calling this area of study artificial intelligence, right? Then, well, we have been through a journey. We have been learning and producing more outcomes as in, hey, what do we do as humans to see, to communicate, to, you know, how can we actually replace this with a set of instructions and have a machine helping out and going through that journey, right? So it's been a journey. I mean, we have been questioning, how do we as humans work on an assembly line, or hold a conversation with other humans, or reason about our own actions, or play chess, or, you know, how do we respond to feelings? How do we vacuum our home? How do we chop? How do we talk to each other, right? So it's replacing or pretty much augmenting our intelligence with this set of instructions with a specific outcome. And at the end, all of this is data, because we have been digitalizing our own traditional problems, right? Back in early 95, or when I moved to the United States, it was a big deal to call to Colombia because it was an international call and it was very expensive. Now we all use WhatsApp, and we have a completely different set of tools that allow us to communicate, but at the same time are transforming that into data, right? Structured data, unstructured data that needs to be consumed, that needs to be processed somehow for us to make the most out of it. So structured and unstructured data, or that amount of process, we have to have a piece that help us process all of that. One thing is the software that you put on top of a hardware that allows you to process this. It's a yin yang, right? We have to have all the pieces of the puzzle that are fundamental for machine learning and AI to work together, and has been improving tremendously during the last decade. Because at the end, AI is a set of instructions. It's a set of instructions for a machine to compute. And for that computation to happen, you need a hardware to process those instructions by the software, right? So this is a beautiful analogy here where we can see how this power, computational power, has been increasing exponentially during the last 2 or 3 decades or so. And a good example is, think about the first memory stick that you had. How much memory was there? How much money you paid versus how much money you paid for a memory stick today? How much extra memory you can have there, and it can be in the same or even a smaller physical space, right? So right there, you can see that exponential growth. We have way better computation resources now to run more powerful algorithms, and this is allowing us to empower our teams, right, with better resources to compute more data faster and to perform harder operations, right? That is opening the contribution to everything that is going on recently. So we have now more powerful computations that are going to allow those algorithms to go deeper into what else we can do. And we see advances still today into neural networks, into speech recognition, into techniques that we use as part of a data science workflow today. So here are some of the key players that are still making contributions to the field and that actually generate what I call the perfect combination, right? So just to recap so far, at this point, we have a lot of math and statistical principles, right, behind the scenes. We added to that some computer power and the desire to understand and augment our human intelligence. And of course, lots of data, data all over. So this allows you to have this perfect combination for the artificial intelligence field to actually grow into different categories, right? So this is going to continue to grow, but as we continue to understand and simulate our own human intelligence, we will see different ramifications of this artificial intelligence. So, for example, as humans, we can communicate. That is the speech recognition using all the statistical based algorithms. You have humans that can write and read text and language. So you have the area of NLP growing over there. You have humans that can recognize the scene through your eyes and create an image for the brain to process it. Then you have the computer vision and all that field over there growing as well. The humans can understand the environment and that can move around fluently. And that is the field of robotics that is also growing over there. We as humans can see patterns. So then you have the pattern recognition field, right? How machines can use more data and dimensions of the data growing into the machine learning field. And then you have a human brain that is connecting these neurons and is allowing artificial intelligence to also create a new field that is this network, neural network and deep neural network, and so on, as we continue to learn more and more and more on the way that we think, right? So we end up with a lot of examples out there today, right? So AI is all over, and we have had AI and machine learning all around us with multiple examples that I'm sure everybody here is very familiar with at least a couple, right? You are watching a movie on Netflix and you finish your movie and it's recommending you which movie to see next, or you just went to Amazon and bought something and the algorithm is actually suggesting what else to buy based on that purchase. Or you are trying to communicate with your device at home, hey Google or Alexa, and that is the NLP and the speech recognition that goes behind the scenes for you to communicate with these machines. So back to our breaking the silos concept, right, which is our talk today. What kind of silos do you have here and how that can actually be not so optimal in terms of the outcome of this model, right? Let's think about these examples and let's think about what needs to happen behind the scenes and how silos can be behind the scenes of these examples. The device that responds for voice command, for example, we can have a very nice silo if we use somebody like me with a Colombian accent, for example, to process those voice commands and I'm talking to a microphone, I am processing that data, I am transforming that data into ones and zeros that I can use into an algorithm, but I train the algorithm only using my voice and my accent. Well, perhaps that's a silo, right? What if this machine is going to be deployed worldwide and you need to have a way more diverse set of people providing commands for the algorithm to be trained. That's an example. Or let's train a model that will predict from a scan if there is a disease, the top right example, right? So in this case, the model can be very accurate using that specific silo of data to train the model. But that silo could be, oh, we only had data from female patients that were between 20 to 30 years old. And then we're going to train the model with that data. And then we're going to deploy that model. Well, what happens if we have a completely different set of data over there and we're using the same model? Is it going to be equally accurate if we have a male that is 65 years old and shows slightly different scans? So all of those are examples of silos, because at the end, AI is a tool. And as a tool, it requires the right settings for it to be configured, right, and to work properly. So what are these settings? What are the right settings, right? What it means. So for that, I'm gonna highlight the algorithm concept, right? So what is an algorithm? At the end is a simple set of instructions, right? You are trying to complete a task, a specific task. And I see an algorithm as these building blocks for programming, right? They are gonna allow you to do things with computers or with smartphones or with websites. You are going to interact with it, right? And in addition to being used by technology, a lot of things that we do on our daily basis are very similar to algorithms, right? So these algorithms are not magic. They are not one silver bullet that you can use and solve a problem or simulate a problem or create an outcome that you can reuse across a team. There are part of the tool, and there are part of the tools that you can use to optimize an outcome, right? So at the end, let me just show you, if we think about an algorithm, and if we think about the fact that you can actually need to evaluate where this is going, right? Because at the end, you have information that is coming from all of these silos, and you have the tools, but at the end, you need to combine all the knowledge and all the tests that you are building into these tools before evaluating if your data science is actually kind of accurate. And there are so many variables that are involved in here, but just this visualization is to highlight the fact that data science actually is a team sport, and that collaboration is a crucial component of it, and that it does have a sweet spot, because you can be creating a model that is very simple with a higher probability of bias. That is where you are in this area over here, and you say, okay, is my model too simple? Do I have enough variables here? I am considering all the silos that I should be considered as part of this bigger problem, right? Or you can be decreasing on that augmenting on that model complexity, when you can actually tackle this with more advanced tools or methods to evaluate if the sample that you are using is correct, or if you have some kind of bias. You can run tests to actually explain the univariate, bivariate analysis, principal component analysis, what if scenarios, right? Here is where we are including all the SMEs as part of that bigger picture, right? It's like, okay, you are the expert. Tell me, is this data is being represented properly? If this preliminary outcome of my algorithm is making sense based on what you know about this field, right? You are the expert about it. So you have to be very conscient about the sweet spot of data science, because you can easily go to the other side as well. When you have a very complex model and you are using way too many variables to process. So you can go into the variance probability there, where you are saying, hey, is this model too complex? Do I have too many variables? Is this too much, right? So at the end, not everything goes as planned, right? There are things that not necessarily goes as planned, and I'm gonna show a couple of examples. So what happens when AI systems get it wrong? Well, it can actually be impactful, and these errors can actually cause harm. I mean, bias is inaccuracy, right? So you want to ensure that you are breaking the silos, but you also want to ensure that you are including all the insights that you have to be including when you are producing an outcome that goes with a machine learning or AI algorithm, right? So you want predictions and recommendations to be as accurate as possible. Bias of any kind can decrease accuracy, right? And can lead to poor model performances. And this is part of what we are dealing with, because we are digitalizing our culture, our data, how we communicate as humans. This is the outcome of chatbots or Twitters or Facebook. At the end, we are digitalizing all that information. So when we create an algorithm, being conscient about the outcome is a key component of it. So are you considering everything you need to be considering when allowing machine learning and AI to make decisions, right? Is the vulnerable population considered in our models and solutions, right? So we're going to be using the data coming from all the silos, and this gives you great power because information is power. Silos are information. The more you know, the better. But the more you know, the more responsible you have to be when creating these kind of cycles, right? So at the end, machine learning is the machine running an algorithm. And an algorithm is a set of instructions, and it can be it is very hard to achieve common sense with AI. That's why we are the humans, and that's why we are part of these processes. So this is a very simple example to highlight how achieving common sense with AI is hard, and it can be very hard. So in this video, I have an objective function. So this is an algorithm that has an objective function that is to maximize points. And the condition is you maximize points by hitting the green targets. Okay, let's see what's going on here. Oh, the boat is doing phenomenally. I mean, the algorithm is working, is doing exactly what it was told to do, is maximizing the amount of points by hitting the green targets. But what else is happening? Well, the boat is hitting the green targets no matter what. So if you have another boat, if you run through it, too bad. If a pedestrian is walking through the port, too bad. If you have anything else that is considered for us as humans, something more like logical, like common sense, like, okay, I'm gonna run through my green targets, but I'm not gonna run through the boat or through the pedestrian that is actually walking around. So transparent AI and responsible AI can become extremely important, right? It's gonna be part of that flow. So we're working as an extended team, incorporating the different set of skills to connect all the right silos, right? You're gonna have to clean that data. The silos bring garbage, bring data that not necessarily has the best quality of the data. Sometimes silos are not only across databases and data sources, but also across third parties, cultures, countries, and communities. And we're going to see a couple of examples of that. So you will also have to include as part of that, not only the breaking the silos part, but also the let's talk about this data part. Let's collaborate about understanding this data and what these variables bring into the table and how we can maximize the insights into this data, right? So you will have to clean and transform the data. You will have to identify the best model based on the questions that you are asking to the data and based on the outcome that you are thinking is going to benefit us. And when I say us, I am thinking us as humans, right? So let's ensure that we are working on this to benefit us as humans. So when we accomplish that balance, what happens when AI systems get it right? Many things, right? So you are breaking the silos, meaning you have a better picture of what is behind the scenes. So you are removing those horse blinders. You are incorporating different variables, literally, because at the end, when you break a silo, you can be combining different data tables and you can be adding different columns of data, variables that help you explain that system. What is it that I'm going to try to do with this data? Who is going to benefit out of this data? What can I do with this data so the outcome is good for us as humans, but at the same time, it's representing what it needs to represent from the data perspective, right? So many things can go very good when we have all the proper elements as part of this data science pipeline. You are breaking the silos, but you are also collaborating, understanding on what that data means, and you are making the most out of it. So I will share some examples where data science pipelines are behind the scenes, allowing the teams to collaborate and make sense, right, for those silos of data that you have down there. And we can talk about the last 18 months or so that we have been going through as humanity with these new circumstances of working remotely and so on, and how tools that allow all of these teams to break these silos, but at the same time to collaborate on this data cleansing, data manipulation, understanding of the data, understanding of the potential models that you can apply from the machine learning perspective, and the most important thing, the outcome of it, right? Who is going to be asking questions to this data? What kind of benefits that person is going to have? And how we are going to ensure that the whole data science pipeline that is behind the scenes is supporting that ultimate goal? And what else are we going to do to ensure transparency into that process, right? So what happens when AI systems get it right? Many, many good things can happen, as I mentioned. And if you are interested about more examples of how teams are collaborating, breaking silos, and bringing insights across borders, across countries, across cultures, right, for a common goal that benefit us, in this case as humans, I will say check out the URL on the bottom right on the website for more examples. But today I'm going to talk about the ocean cleanup project that is also showcased on this website. And I'm going to talk about this project from beginning to end, highlighting the multiple silos that are behind the scenes, highlighting the importance of collaboration between teams, and showcasing the outcome, right? What happened after. So this is a beautiful example here. Did you know that plastic can take up to 1,000 years to biodegrade, and only a small fraction of what we produce ends up being recycled, right? So this is a serious damage to the world's ecosystem. This is one of those projects that have an impact, that but at the same time is going to include a different set of experts and different silos to try to fix the problem and have a common outcome or goal. So where does data science come into place with this? Let's think about plastic pollution, right? That's the big picture. Plastic pollution is a complex and overwhelming problem, and data and technology, here we go, our Dataiku solution is actually giving the valuable insights across the silos, but at the same time providing the platform for this to be transparent, to include the SMEs, to include the different models that need to be included, and to accomplish an outcome that benefit everybody here. So essentially, you are processing data coming from different silos. So let's talk about the silos behind this project. You are cleaning plastic from the ocean. So silo number one is, how do I know this is plastic, what I'm cleaning, right? So let's start silo number one, drones. You have flying drones that are taking pictures and videos of a specific area in the ocean. So that is your first silo. You are going to process that data. You are going to transform those images into ones and zeros. You are going to clean that data, and you are going to use it to train an algorithm that is going to define if an object from a picture is plastic or not. Simple. Then what? Well, you have to maximize the way that this robot is going to move. At the end, you have two arms, robotic arms, that are using natural resources to move, meaning they are using solar power, wind power, and waves power to actually move those arms. And in addition to that, you want to move to the place where you have the most plastic bottles, right? Because you are trying to maximize the move of the robotic arms to clean all that, and to ensure that you are moving to the right place, and the right place is the most plastic bottles. And then you are using the resources that are being produced by the transformation of the wind direction and the waves and the solar into the energy that the whole system is using. So the different silos, you have the drones that are bringing the visual, which is the image processing, but you also have a lot of sensors measuring the current, the waves, the wind speed, the wind direction, the weather data. And then you start putting all of these teams together, right? You will have experts in wave movements. You are going to have experts in renewable energy. You are going to have experts on weather forecast, that at the end, all of it is pattern recognition and a couple of machine learning algorithms, right? So recognize if I have plastic or not, recognize what is going to be the weather based on this forecast for the next hour or two. Can I maximize the use of the resources? I can actually move in that direction to process this information and take it in. So the data science project here, the goal, maximize the use of the resources. Here we have the robot arm that is using the power coming from the hybrid system to where and how to move the mechanical arm to optimize the amount of garbage that will pick up, right? So let's go back to our original analogy, remove the blinders, right? So a silo, we represent it as a horse blinder, and this is a beautiful moment to highlight that again. Back to the horse blinders analogy, think about the drone as a silo, but then add that with a purpose, which is cleaning the ocean, and all other data coming from all the other silos, like wind speed and the direction and the current and the weather and the waves, and you have a very powerful outcome, right? So very powerful outcome for this specific project, where collaboration was key. A group of experts relating weather experts, ocean experts, mechanical engineers, data scientists, data engineers, analysts, working together and allowing the experts question the data, right? Tell me about this data. Okay, well, ask the questions to the data, put together the data science pipeline behind the scenes, and generate an outcome. And this is a very, very tangible outcome. So this is a machine following instructions, but in a consistent way, right? So it's like, okay, this is making sense. Our collaboration here makes sense. And this is a great opportunity for us to empower the teams and to be the humans. So we are the humans that are maximizing the use of these silos, that are maximizing the use of these enzymes, but that at the same time will be aware that information is power, and that now more than ever, we need to collaborate and be the humans to monitor the outcomes, right? So you are gonna interrogate the data, you are gonna test the models that you are deploying, you are gonna question the AI system, you are gonna be the human that is actually validating the outcomes, or the human that is asking the expert when validating the outcomes, right? Because you need to understand that model drift is a reality, that your data is going to change, that that model is not going to be accurate forever, that perhaps you need to maintain eyes into guard bands, checking that the model is doing what you think it's doing, right? So transparency is important. At the end, who is going to make decisions with this data or with these models, and how that can affect us as humans, right? As society, as a community. So keep in mind that all the data is shaped by history and context. So do not take numbers to be an impartial source of truth. And this is important in terms of bias and outcomes that can actually affect our daily basis. But at the same time, be aware of the power that bringing, that working as a collaborative team brings to the table when breaking these silos, right? So remove the blinders. Here it is. Empower the people. Embrace the skills that all these teams bring to the table. They're going to be working as this one extended team. So as a community, We're going to maximize the insights into this data, maximize the outcome that we can reach, but just keeping basic transparency and responsible flows when breaking these silos, right? And this is another thing. I believe that the bigger the project, the more collaboration will be needed, right? The more silos you break, the more collaboration will be needed, because the more silos you break, the less information of how to connect those and how to bring it together is available. So talking to the experts, asking questions about the data, ensuring that the teams can work together becomes a key component of a successful project that involves breaking a silo and doing something with that data as part of the data science workflow. So another example, and this is regarding the bigger the project, the more collaboration will be needed. Think about the decarbonization of the planet initiative that is going on globally, right? And how in Texas, especially, we have been talking about energy transition and how energy transition is a big part of it and all of that. So renewable energy, this is a quick example. The bigger the project, the more silos to break and the more important to collaborate within each other, right? So we are all talking about renewable energy, how we're gonna do this better, how we're gonna maximize the use of the energy that we can bring from the wind turbines or from solar, offshore, onshore. And then all of this starts to get together as in, oh my gosh, there is a lot of third parties involved here, because we are thinking about many things and there is a lot of silos about around here. And we bring different parties thinking about what they need out of the data. But at the end, we need to think about this holistically, right? How are we going to do specific things with these predictions? I mean, are we including the land information? Are we including the elevation information? Are we including how to predict how much energy you will have? Or you need to think about the landowners or the county incentives or the state incentives, or, you know, all of these become silos, data, 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 data. And at the end, we are collaborating to have that outcome in a transparent flow where we can actually extract the most out of those data and still ask the questions that we need to ask into that data, and ensuring that it's giving us what we expect it to be. Okay, so I'm going to highlight a couple of conclusions before the end of the time here. I want to ensure that I show this flow, because the most important part of this flow is that human over there, right there with the yellow glasses. So break silos, get to know as much as you can about the problem that you are trying to fix, collaborate with the extended team to ensure that the SME, the subject matter expert, feedback is part of the loop, right? That needs to be part of the loop. You have to be responsible AI, as they ensure that you have the safeguards for the human rights, right, and protect data we are entrusted with. And the more silos you break, more responsibility comes, because you will have access to all of these insights. So how are you going to use that? It has to be accountable, right? You have to seek and leverage for feedback, for continuous improvement. Involve the extended team. Involve the team that has nothing to do with the skill set needed to transform this data or to create a machine learning algorithm to it, right? It's the expert that is receiving the outcome from this. You have to be transparent. You have to develop a transparent user experience to guide users through machine-driven recommendations, right? That cannot be blinded. It has to be guided. And keep empowering these teams. I mean, the technology is there. The technology is going to allow you to work in a collaborating way. It's going to allow you to break the silos, because it's going to allow you to connect to all of these data sources. But that outcome and how you get there and what you do for the cycle to be transparent, accountable, responsible, all of that is where the human as part of the flow is a huge component, right? Is this model doing what I think it's doing? Is the outcome as expected? So measure what matters. Always measure what matters, and go back and ask questions. Is this what I was expecting? Think outside the box. Who else is going to have an outcome regarding this workflow, or is it going to be positive or negative? Like, what kind of consequences we can have as a society? So AI is a tool, just like a mobile phone, just like the internet. And it shouldn't be a goal in it itself, but the goal is how we're going to use it in our advantage. So the more silos you break, the more information that you have, the better decision you can make, the most educated the decision you can make. And also be aware of the data that you are bringing to the table. So be the human, but include the extended team, right? You are working with the data scientists, with the business users, with IT, with the data engineers, with the analysts, with the developers. Ask the right questions to the data. Data is way more than numbers, and it can come with a heavy component of biased data itself. So be very aware of the sample that you are working with. Ask questions about how often that data needs to be renewed, how often do I have to retrain the model, and so on, because data sources are sourced from a lot of context or bias component as well. Now, having the full picture represented by the data is key. So always ask the expert, right? SMEs, who knows about this problem? Who is the expert about this problem? Even if that person has nothing to do with data science, data manipulation, analytics. But at the end, that person is going to validate the work. Okay, yes, all of this is consistent with what I have seen in life, and the data is just reassuring my expertise, right? Be responsible. Think about the consequences. What can go wrong? It can incorporate responsible AI and transparent AI as part of your digital transformation strategy, because I have no doubt collectively we are more intelligent, and I have seen it again and again, and I have no doubt that that is the way to do so. And with the proper tools, we have a beautiful path to be very successful in these kind of projects when we are actually breaking the silos and making the most out of this data. I'm going to stop right there, and I'm going to open it for questions. I think this is a good time to see if we have any questions from the audience.
Thank you, Catalina. So that last statement is can be the definition of the central limit theorem, right, in statistics. It applied to collecting information from experts as well. So that was a very nice close in there. An excellent presentation. Thank you very much. So any questions from the audience? Billy.
We have one from Billy. Yeah.
Yeah. Hello. Thank you very much for the talk. I have one question about the recent hype on AI. We've seen a lot of success, but if we look at history, especially in the 1960s, when Professor Marvin Minsky, one of the pioneers of AI, said that we will have a fully working AI that is substantially evolved, but it turned out not to be the case, and the academic and the industry experienced the first AI winter. Mm-hmm. The same thing with the 1980s, when 1990, I think, when they take on, expert systems, like a new take on the symbolic AI. It also turned out not to do well, and thus experienced the second AI winter. So as someone who is fully immersed in the industry, what is your take on this?
Yeah, that's a great question. And there are a couple of key components that actually affected that outcome. So the number one, I think is the most important one, is back in 1956, we were trying to kind of replace human intelligence. And I think the big tweak in artificial intelligence history is try to augment our intelligence. And the computation power that came after, it's a huge component of it. So to answer your specific question, at the beginning, we were trying to, reproduce. we actually crossed a line as humanity. We're like, okay, let's see how this can actually help us augment our intelligence instead of replace our intelligence, which is where I see the use cases that are applicable to the industry, the successful use cases that you were referring at the beginning, the boom of the use cases that we are talking today is because we are augmenting what we can do. So the computational power acceleration in the last 2 decades is a key component of that, because before we didn't have the power to run some of the algorithms that we are running today and the data, right? So 30, 40 years before, you have a completely different sample of data to train a model or to consume it in any producible way. Today, not only the compute power that is allowing you to process way more algorithms, way harder algorithms using all of these machines in parallel, GPUs, CPUs, and all of that, but in addition to that, the technology like Dataiku that is actually allowing different people with different skills to still have access to this data and to start asking questions to this data. So that was part of the situation that you mentioned at the beginning with the winter and so on. Computational, we were limited. So that was a big line. And the second line is the technology that is available to consume and process this data. Now it's not so limited to a subset of statisticians or PhDs that know how to put together an algorithm. No, now it's pretty much an extended team that understands the power of data. And the tools and the technology right now are completely different from 4 years ago. And right now we can actually empower a team to go through a data science pipeline from beginning to end. So that's what you see the boom here, where these industries are actually able to consume their own silos, to consume their own data, and to do something with it, even if it is a simple forecast, right? It's like, okay, in my time in high school, y equals mx plus b. Well, that is a whole new level today when you have multiple silos and when you get a team to collaborate into that use case. So I hope that answered your question, but 2 components, the computational power and the technology that allows a team to work as an extended team, taking out those silos, not only from the data perspective, but also from the collaboration perspective. And that is the big picture that I'm showing to you right now. And that is the boom. We can use it now because we have better tools to access those silos.
Thank you, Catalina. Matt Cochran, our research director at CBTS, you raise your hand. Do you have a question or comment, Matt?
Yes. Just quick question. Catalina, given the Dataiku is apparently kind of, I don't know if democratizing is a good description because you're closer to this in expertise than I am, but making this pipeline available to more collaboration and in these experts. So there's this concept of kind of making it more accessible, but at the same time, it seems that data intensivity and then the kind of need to really harness that may lend itself to the big getting bigger. Consolidation is something common across industries now. Digital transformation is, I think it's a fundamental thing that everybody is facing, no matter where they work or even if they think about data on a daily basis. But there's also this concept of the big tech, the big getting bigger. And I can see applications like for teams within, a company or something, but I'm just kind of curious if you see that AI will, and the kind of data intensivity and then silos and harnessing silos, sometimes in business, there's just this M&A, there's acquisition. If you don't own it and you want to be the top 3 in the world at something, you go and you buy it. And so soon you own silos and, maybe you put your teams together, but then there's this kind of trend perhaps toward consolidation. So I'm wondering if you think that the tooling and availability of tools like Dataiku will allow indeed more kind of across the board access, or whether the big just keep getting bigger and better at things like AI, at solving problems and capturing headlines Yeah,
we are getting better and doing so. That's a great point. And big is gonna get bigger, and we are only gonna get more data by the minute, like no doubt. We are collecting, like the speed at what we're collecting data today versus 10 years ago versus 20 years ago is ridiculous, right? Like big data is all over the place, and that is only gonna get bigger. But with these tools, you are allowing not only, it's less overwhelming, it's way more manageable. Like I understand what this data is telling me. I understand how to involve a team that is going to be capable of providing feedback into this. I can still, so the democratization, and you mentioned it at the beginning, I think that's the key word that you highlighted here. The fact that these companies understand the power of the data and how they want to democratize the access to that data and the access to AI, that is the tool, and how to use it and how to put the two and two together. But for it not to become a completely overwhelming problem when you are swimming on data, the more tests and techniques that you can put in place to ensure that you are working with a sample that is as clean as possible, as transparent as possible, as in all the process that needed to happen for you to be there, and how you transition that to a different team member. So let's say you have a group of people that is consuming that data, transforming it, and so on. But then you have a completely different group of people that is actually asking questions to this data or consuming that model in a completely different way. So the fact that we can now connect the dots behind the scenes and empower this collaboration as an extended team, and that I think that's a key component of this, that is what is making this line. Because data is going to get bigger and bigger. Things are going to get bigger. But now you have the possibility to have it under control and to use those skills of people into something that is pointing to the same direction that was the previous disconnect. I have been in tech for 10 years, right? And the infrastructures on these companies, well, they are all doing acquisitions and they are all adding stacks. So they have their own stack and their own set of data sources and thing. And a year after, it looks completely different. And a year after, it looks completely different because they're going to keep growing. They will have digital strategies. They will expand into data, a stack that is supporting all of these data sources and all of these big data. But at the end, what Dataiku brings to the table is that future proof in terms of the technology. It doesn't matter. We're going to keep orchestrating the team to work together, connecting to those data sources and maintaining that stack. But the Dataiku solution is resilient from that infrastructure. And that's a huge key right there, because you are right. This is going to continue to change, and it's going to be more, and it's going to be more data. So the better we can actually connect the dots together, and the better we can ensure communication across teams together, pointing towards the same goal, that's the key of a successful data science business, and that's what Dataiku brings to the table.
Okay, well, thank you. Yeah, it's nice to hear, given my AI wasn't working right, so I hit the wrong Teams link, but it's nice to hear from the academic in the academic side of things, because sometimes, you know, we're the biggest, we can be big silo makers.
Oh yeah.
It's a very hierarchical system. You know, these institutional organizations have they have their own inertia. So I think we're all, you know, whether there's digital transformation, there's also just institutional transformation, I think, that's
right.
Going, so.
An organization, cultural change that needs to come with it. I agree with you, 100%. Yeah. Very
good. Well, I just want to probably close the webinar with that particular topic that Matt mentioned. So in an academic environment, democracy sometimes is not the best word to describe our working environment. And that is by definition what nurtures innovation. So creating high competent, highly intensive competence among different actors, right? But from the administration point, I mean, that's from the intellectual property point of view, but then from the administration point of view, so now we're veering into, I mean, we also have that other force that is pulling in a different direction, saying, wait a second, we need to maximize the resources that we have. You need to have multidisciplinary collaborations. You need to have, break the silos. But at the end, we're going to evaluate you individually, not collectively. So the merit is personal, is not collective. So the way we're being assessed in an academic environment is very different to the way a team member is assessed in a business that is trying collectively to reach the best goal possible, or achieve the best goal with the best possible program performance, etc. So I guess the challenge is there. I just wanted to close the webinar, which is why we are very much interested about learning what you guys are doing, and see if we can set up a partnership if possible. And I'm very glad that our director, our research director, our executive director has been present in this presentation for CBTS, and a number of students that are also learning about what you presented today, Catalina, and what Dataiku presented today for us. So thank you very much for your presentation, and look forward to having a follow-up conversation about how to better set up this partnership or collaboration. Very good, and thank you everyone for joining us today. Have a great day.
Thank you.
Thank you.
Very good.
Thank you.
Thank you.
Thank you.